Hello guys, hope so you all are doing great. Today we'll be looking at R square and R square adjusted. What is their math and what is how it works, okay? What is R square, okay? Now, the equation for R square, or I'll say the formula for R square, is a pretty simple formula. It is 1 minus sum of residuals. Sorry. Let me just use a different pen here, okay? R square is nothing but 1 minus sum of residuals by S total. Okay, what is SS total? It is sum of total averages. Okay, I'll tell you what it is. Okay, don't worry. 1 minus sum of all, or summation, yi minus y hat. If you remember this from my previous video, what is y hat, by whole square, and divided by sum of all y, again yi, minus y dash I whole square. What is yi and what is y dash I? Okay, and why we are using square here? The first thing is, let's see what is yi. So if you remember that in previous video I told you that yi is nothing but the predicted points on the best fit line. Okay, so if I have a best fit line like this in a linear regression, let's say these are my actual points, suppose. Okay, let's say these are my actual points. Okay, and this is my actual point here, this is my actual point here, and these are my predicted points right here. Okay, we have some here, and the difference between the projected points and this is our sum of residuals. Okay, yi, the actual points, minus the y hat I, which is the predicted points here. Okay, got it? Now what is our y dash I? So basically, instead of actually drawing a best fit line, what we do is we create an average line. What is average line? Basically, we take the points and we calculate the average predicted points and we just placed it. Okay, these are just average values. Okay, so this is a straight line like this. Okay, so there will be some basically points like this. Okay, these are my average predicted points. Okay, simple. And how my points will be passing through it, like in this way, somewhat this way, not exactly like this, but let's say like in this manner. Okay, and here, maybe here also. And what we are going to calculate? We are going to calculate the difference between these points and our predicted points. Okay, this is not an accurate diagram, but you can understand it. Just we are doing the difference between the actual points minus the average point here. Okay, in the line, but the predicted point are average point. Okay, now if the answer, why we are using square? Okay, one thing I wanted to answer you, why we are using the whole square. We are doing square, so if we get a negative value, okay, if we are getting a negative value, that gets positive. Okay, that gets converted into positive values. Only that is the reason behind this using square. Okay, simple. Now in a right scenario, when our model is a good model, our R square always is greater than 0 and it keeps on increasing. Okay, it keeps on increasing itself. Okay, as our iteration goes on, it keeps on increasing with other features. Okay, now if you remember, well, and if suppose R square is decreasing, okay, if R square is less than 0, first of all, is it a possibility that it can be minus 1, or basically it can be less than 0, let's say? So yes, there is a possibility of it being less than 0, but if it is less than 0, that simply means your model is nothing but a dump model, okay, or it is the worst model, I'll say. Okay, it is the worst model. Your best fit line is not properly created. That means you need to again do something to basically create a good best fit line. Okay, so if your R square is less than 0, that means you have a worst model. Simple. Hope so you are getting it. Now, what if our R square, I told you that R square keeps on increasing, okay, it never stops, it never decreases. And why? Because obviously with many more iteration, this thing will get lower down, okay, this thing will get lower down. And when this thing whole gives a small number, 1 minus small number is nothing but a bigger number, okay, it will keeps on increasing. So if suppose we have let's say for first iteration it was somewhere around 0.8, okay, and we get something like 0.2, and second it gets like 0.7, 0.6, 0.5, so it will keep on increasing, right? And that's how we know that it will keeps on increasing with more features. Okay, now let's say we know that our equation for multiple features is nothing but b theta plus b b1 x1 plus b2 x2 plus b2 b3 x3. Okay, this is our equation, right, for multiple features till whatever features we have, b and xn. Okay, now suppose these two features are correlated, then our R square is increasing, right? Our R square is increasing. That's great, there is no issue with that. But let's say b3 x3, when we comes to this feature was not correlated. Alright, it was not correlated, right? It was not correlated. Then what? Obviously it will keeps on increasing. Okay, if it is not correlated, it will keeps on increasing. Okay, why is that? Because of the equation above that I have shown you. Okay, because of this equation, right? Now this thing is not good, right? If our feature is not correlated, then we need to penalize that feature, or basically we need to penalize the R square value, and it should get decreased rather than get increased. Okay, so for this reason, because of this problem here, okay, because of this problem here, we do R square adjusted. Okay, we do R square, or we use R square adjusted. Now what is the formula for R square adjusted? It's a very simple formula. It is 1 minus R square, okay, multiply by n minus 1 n minus p, okay, minus 1. Okay, now what is p here? Let me just write it down. P here is nothing but predictors, okay, or number of predictor, you can say. If you don't know number of predictor, that I mean basically nothing but these are features, okay, or independent variables, independent features. Okay, R square is nothing but sample of R square. N is total number, basically total sample size. Okay, now understand this equation, as this is very important equation. Okay, understand this. Okay, what is happening here? See, I told you that R square will keeps on increasing, right? Suppose a correlated features comes in, what will happen? R square will increase. Okay, this equation n minus p minus 1, as I told you, this is total number of samples. So for first iteration, let's say for first iteration, n is what? It will give us total number of samples minus what? The predictor itself, the number of predictors, then it is minus 1. Okay, so if my R square, or if this thing is basically right, if it is correlated, if my feature if my feature, okay, learn this thing, okay, if my feature is correlated, then what happens? R square adjusted keeps on increasing. Okay, if my feature is correlated, R square will be increasing, and n minus p minus 1, this whole equation will be a low value. I'll not say a small value, it will be a small value. Okay, even if this whole part here, okay, this whole division part here gives us some not small value, let's say some high value, even if it gives that, our R square will be higher, and again we are doing 1 minus R square, so basically it will be increasing if it is correlated. Okay, if it is not correlated, what happens is our n minus p minus 1, or basically our R square adjusted, let's say R square adjusted, if it is correlated, it starts to decrease. Okay, the same thing that I told you for the above thing, it will start to reverse itself. Okay, just because our R square will increase in a higher way, but this won't be increasing in that way. Okay, and that's why we will be getting R square adjusted to be in a decreasing way. Okay, so that's why we use R square adjusted, because whenever we are getting a correlated feature, or I'll just write it down here, just remember this thing, whenever we get a correlated feature, our R square adjusted keeps on increasing, and as we get any non-correlated feature, it penalizes and R square adjusted starts to decrease, or basically R square adjusted decrease. Okay, hope so you were able to understand how R square adjusted works and why we use R square adjusted and what is the R square. Okay, and basically it is used for actually analyzing our model, how well it is working and how great our best fit line is. Okay, that's all for today. Hope you all got it. If there is any doubt that you want to ask, you can ask in comment box. Hope so you liked the video. Please subscribe to my channel, share it with your friends. Thank you for watching. Bye bye.